All right, guys. Well, welcome back to the next two sections of chapter 2. We started the first one last time and introduced some of the main things that we're going to be using and talking about. So before we actually do that, I wanted to give you guys a little warm up, if you will, to try to see if you guys are, without using notes or a calculator, starting to memorize those things that we discussed last time that I told you are very, very important. So I'm going to go ahead and pause it right here. I'll give you guys a little bit of time to go ahead and do this, maybe 3 minutes, because remember, I want these to be like your math facts in elementary school. I want you to be able to look at the sine of 30 and tell me immediately what it is. So again, it's kind of the honor system here. Go ahead and take a few minutes. I'll give you 2 and do that to the best of your ability. Ready, go. All right, let's see how you did. How many of these did you know? Out of the 12, anybody remember any of these off the top of their head without using notes?
I got up to F.
Yeah,
Good.
about half of them.
Good. Yeah, and we didn't really go over the cotangent stuff, but we did go over the fact that all of these sines and cosines, this is why I kind of paired them the way that I did, are what kind of functions to or compared to one another. They're co-functions, or what we call complementary functions, meaning that when their angles are complements, their ratios will be the same. So virtually what I did here is, if you knew the left column, then you also know the right column. So when you say you got up to F, that virtually means that you had these 3 memorized, right? So all you have to do is memorize the tangents and you will know the cotangents. Memorize all the sines, you will know the cosines, and so on and so forth, secants and cosecants. So I don't know if you remember, for those of you that were there or those of you that watched the video back, this is what I gave you to help you memorize each and every one of those. And do you remember the tricks that I helped you to remember and start memorizing these? If not, I'll go over it one more time with you. Go ahead, Luis.
I was going to say that you started from 0 to 4 on the top one, and then you went backwards on the second one.
Very good. Remember, we want to just stay in that first quadrant, right? When we cut it into 4, we're just staying in quadrant 1. So we start at 0 degrees, and then we went to 90 degrees. And we wanted those special right triangles that we dealt with, the 30, 60, 90, and the 45, 45, 90. And since we're going to start at 0, we start with 0 for sine. And we always start with sine because, remember, this is cosine. It's the complement to it. And since we're going to stay in that first quadrant, we're going to go by 1 all the way up to 4. And then notice, since these are complementary functions, then they complement one another. They all add up to 4. And with doing this, we know it will save us half the time. That was my little joke to remind you, you got to cut all of these in half. And then you can't forget to take the square root of the tops of all of these. Then all you had to do was simplify. And I'm going to simplify a little bit differently than last time. I'm going to make sure that you guys see that you know the square root of 0 is 0. Divided by 2 stays a 0. But then I'm going to hopefully see that the sine of 0 is 0. Well, then so is the cosine of 90. it's also 0. And why do I know that? Complementary angles, complementary functions. Well then, what is the sine of 30? Because I know that's going to be the same as the cosine of what?
60.
Again, complementary angles, complementary functions have the same ratio or value out. And very good. Square root of 1, 1, divided by 2, 1/2. 1/2. So you see, I'm really only doing half of this to get 2 rows. Root 2 over 2, nothing to do. And notice 45 and 45 adds up to 90. So sine and cosine, same ratios. Root 3 over 2, same thing, nothing to do because we don't know the square root of 3. We don't want the approximation with our calculator. Leave it as the exact. And since it's 60 for sine, we know it would be 30 for cosine. And lastly, the 90 for sine or cosine of 0. Because again, those two things are complementary angles and these are complementary functions. And we know the square root of 4 is 2 over 2, which is 1. Now, some of you guys said, okay, well, now that I have that, I can use it for all these. But remember, I asked you to just do it by memory. So there are a few that I'm going to tell you to memorize that are very simple and easy, like the sine of 30. Do you remember what it was when we just built that right there? What's the sine of 30?
1/2.
Very good. That's an easy one to remember. And if we know the sine of 30, then we should also know the what?
The cosine of 60.
Beautiful. And again, that's why I paired them up row by row by row, even though I called it part A, part B, C, and D, and so on. Okay. Well, then remember the 30, 60, 90 was the one that had that. If this is my 30, this was the 60, and this was the 90. Opposite the smallest angle is the smallest side. We called it A. Opposite the biggest angle, the hypotenuse we called it, had the biggest side, and it was twice as big. And so if this is 1A and that was 2A, remember we used the Pythagorean Theorem to find that the one in the middle, the 60, has to be between 1 and 2, and it was root 3 times as big. Where the 45, 45, 90, because these angles were the same, we knew that these sides that they created were the same. And so we did, again, the Pythagorean Theorem to find that since this is the hypotenuse, we know it has to be bigger than the 1A. And it turned out to be root 2 times as big. So when you're building all of these, notice in the 45, 45, 90, the root 2 is involved because it has the two 45s. In the 30, 60, 90 is the one that has the root 3 involved because of the 30. That will hopefully help you to remember that the 30s and the 60s will have the root 3 involved, where the 45s will have the root 2s involved. So since the sine of 30 and the cosine of 60 is 1/2, what do we know that the sine of 60 or the cosine of 30 has to be?
Square root of 3 over 2.
Beautiful. Excellent job, Luis. Well, then what's the sine and cosine of 45?
Square root 2 over 2.
Yep. And all of those, if you have memorized, then these are very simple to find. Let me go back to this real quick. How are we going to find those? Well, hopefully you remember that when we were doing the stuff that we were doing last time, we called this the quotient identity, because if you take sine and divide it by cosine, it's identical or equivalent to, does anybody remember?
The tangent.
Very good. Which, if you can see, we have that already set up. Sine over cosine is this. So all we have to do with every single one of these is put one over the other. And some of these are definitely easier than others, like the first pairing for 0 degrees. 0 divided by 1 is
0.
root 2 over 2 divided by a root 2 over 2. What's anything divided by itself? It's a 1. So the tangent of 0, easy, 0. Tangent of 45, it's the easiest one to remember. And then tangent of 90. What's 1 divided by 0? Can we divide by 0?
No.
Very good. So we said, well, that one is undefined. And then what about the 30 and the 60 for tangent? What do you know is going to be involved? That root 3. And because 30 is the smaller angle than the 60 is going to stay root 3, and the 30 is going to be cut by 3. Now, again, I could show you exactly why that works the way it is if I took the 1/2 over the root 3 over 2 and I manipulated it, right? I actually multiplied by the reciprocal to top and bottom, my fancy 1 again, to get rid of the 2 over 2 and the root 3 over root 3. So the whole bottom became a 1. Now I can just focus on the top. And I know since these are multiplying, these 2's also cancel, and I get 1 over root 3. Which hopefully you remember that was one of the questions I put on that very first introductory group quiz. And I asked you to simplify by, again, having to multiply by a fancy 1 to get a root 3 on top and a root 9 or 3 on bottom. So you can see, I'd rather memorize that because I don't want to ever do all of that again to get this. Okay, so let's go back up here to finish. What then is the tangent of 30?
Root 3 over 3.
Good, and therefore what is the cotangent of 60?
Same thing.
Beautiful.
3 square root of 3 over 3.
Yep, excellent. How about the tangent of 60 then?
Square root 3.
It's in the 30, 60, 90. So we know anytime that the 30 or 60 is involved, it's going to have that root 3. For tangent, smaller angle, smaller ratio. Bigger angle, bigger ratio. And since this is tangent of 60, we know that the complement to tangent, which would be 30, would give the same thing. Like a few of you were saying. Now I said the easiest one to memorize on all of these is the tangent of what? Because we know sine over cosine, they are the same ratio for 45. So when we put this over that, we get a 1, which means cotangent is also a 1. So do you really have to remember 12 things?
Just 6, right?
Just 6. and know that sine and cosine are complementary angles and therefore share the same ratio out when their angles are complements. Add up to 90. That's true for all sines and cosines. It's also true for tangent of our big three, sine, cosine, and tangent, with those big three angles, the 30, 60, 90, and the 45, 45, 90 we talked about. But I wanted to add on cotangent just to hit home the point about complementary functions, or what we call for short cofunctions. Therefore, tangent and cotangent. Okay? So I know we just spent about a good 15, 20 minutes going over that, but I wanted to make sure that I really emphasize the importance of memorizing these, because they are not going to go away, not this week, not next week, not till the end of this class when you're done doing trig. Okay? So now that you have all that down, let's go over the next section for this week, which is 2.2. Remember, 2.1 was titled Trig Functions of Acute Angles. But of course, we're not going to just stay in quadrant 1 and deal with those little acute angles from 0 to 90. We're going to deal with angles of all quadrants. And so I'm going to start by introducing a little thing. Might be important. No, gang, it's one of the most important topics in this entire class. It's called reference angles. Okay, how do we find reference angles and what they are? We're going to talk about that in this section throughout the rest of this chapter into the next, and we'll use it throughout the entire course. Okay, so what are reference angles? Reference angles are always acute angles, which means they're between what?
0 and 90.
Very good. 0 and 90 degrees. I'm writing a little bit larger, so I'll just put it up here. Okay. Good. Now you might be wondering why we're going to study these. Why are they the most important thing in all of trig, basically? And how are they going to be used? Well, let's look at it geometrically, which I just got done saying that all of our reference angles are going to be acute. But remember, the title of this is non-acute angles. What would you prefer? Staying in quadrant 1 and doing all the stuff that we just reviewed? Or getting outside of quadrant 1? I'd much rather be playing in quadrant 1 between 0 and 90 with those smaller angles. Smaller numbers, usually easier to work with. So if I told you to go, say, 135 degrees, that means you got to go past the 90, but not quite to the 180, right? Well, if I asked you to go 135 degrees, what would that mean? Well, don't forget, what's the class called again? You guys must have forgotten trigonometry. Very good. Very good, class. Trigonometry, which is the geometry of triangles. So if they just give me one angle that's, say, 135 degrees, which means I rotate into quadrant 2 about there, I need to form a triangle. Now I have two options. I can go to that point after rotating that 135 degrees, and I could draw a triangle by going to the y-axis. and forming a right triangle. Because remember, we like right triangles. We can use Pythagorean Theorem, all of our trig stuff, right? Sine, cosine, tangent. We need a right triangle. Or what might look a little bit better? Instead of going to our second axis that we added on, the y-axis, what if we dropped it straight down to the x-axis, which was our original number line? Which one? Does it really matter?
Does it
No.
matter?
No, very good, Luis. It doesn't. And we'd still form a right triangle, but to be consistent, let's all do the same thing. And you guys have probably heard that math is the universal language, right? Because whether you're doing this in America, Germany, China, Russia, it doesn't matter. We're all going to be doing trig the same way. It may just look a little bit different with our words and things like that, symbols. But the way that we're going to do this is always to the x-axis, because that's where we started, was the number line. Okay? What we're going to call these reference angles is we're going to do this. That's going to let us know that it's a reference angle. So if I told you to actually go 135 degrees, I'm not going to actually use the 135, even though I got to rotate that 135. I'm going to drop a perpendicular straight down and form my right triangle, which means I'm no longer going to actually use this 135 degrees. I'm going to be using this little part that's left to my x-axis. And who can tell me not only what this angle is, but how they would find it?
It's 45, and I got it from subtracting 180 from 135, or 135 from 180.
Beautiful. Good correction, Luis, and perfect explanation. I know that this was that straight angle, rotating all the way over 180. But if I take this and I subtract this part of it, I'll be left with the little part that I want inside my right triangle. So every time you are placed in quadrant 2, all you got to do to find your reference angle is take 180 minus your angle. And that in quadrant 2 will always give you your reference angle. Now, what's nice about 45? If that angle is 45 and this is 90, I know that if this is 90, the other two have to add up to be 90. And if this one's 45, what does this one have to be? 45. Therefore, we know the lengths of these things would be a, and a root 2. Just like we reviewed earlier today and last time. How would it work if we're in quadrant 3? Any different? Well, this time I would have to rotate past the 180. And so again, if I drop this down to create my right triangle, I want this little angle right here. So when I do that, this right here would be my reference angle. So this time I would actually take my angle, which is bigger than 180, subtract the 180 from it, and that will leave me with the little part that I wanted. And why are we using 180? Because that's where we fall short in quadrant 2 or surpass. We just want to know how much we surpass to get to quadrant 3. Well, then what about in quadrant 4? How would we find that reference angle in quadrant 4? Well, now we're approaching what angle? We're almost all the way around. That's close to 360 degrees. So for this one, since we didn't quite reach 360, we would subtract off the angle measurement that they asked us to go, which remember this is 90, 180, and 270. We'd have to go a little bit more past that 270 to get here, but not quite 360. So all I do is take that full circle and subtract off all of that we had to go, our angle that they gave us, to see what little part is left we call the reference angle. We're really just trying to make a simple or simpler right triangle to work with that reference angle. All right, does that make sense, everyone?
Yeah.
Perfect. Because I cannot iterate again, I'll try, that these reference angles, one of the most important topics in class. Now all you have to do to make them simpler is memorize some of those key angles, so that when we get to a different quadrant than just these acute angles, you can tell me what their value is. All right, so I will caution you that a common error is that people will use the y-axis instead, because they can still draw a triangle. But remember, the reference angle is always found with the x-axis. Why did we not mention anything about quadrant 1 and how to find the reference angle in it?
Because the angle's already acute.
Very good, Luis. You don't need to refer to any angle given a bigger one because it's already in quadrant 1 going to be a 30, a 45, or a 60. Or anything else, but we hope for a 30, 45, or 60 because what? We already know those. And we know exactly what they are. We don't need a calculator to approximate what it is with some big old long decimal. We like to know exactly what things are, not about what they are. Okay? So let's talk about what they would be in each and every quadrant for our big 3 reference angles. And then we'll do a couple examples, call it good for this section. All right. So I put reference angle / quadrant 1. What are the big 3 angles that we know or desire? Good. Somebody put in the chat the 30, 45, and 60. Those are the 3 that we just went over. We reviewed last time, the 30 degree, 45, and 60, or our 30, 60, 90 special right triangle, and our 45, 45, 90. So if we were to go to quadrant 2 or quadrant 3 or quadrant 4, what would we have? to get here? Remember, we said our reference angle would be from 180. If I wanted to get there, there, or there. That's not a very good representation. Let me draw that a little better. There we go. Any one of those, what would I end up doing? We said we're not quite to the 180, but we could come back, subtract off the angle that we rotated to get that little angle that we want. So I would take 180 and subtract 30, and I would rotate how many degrees? Sorry, Luis, I wasn't sure if anyone was going to answer. 150. Does that make sense? If I gave you a 150-degree angle, you would rotate 180, but less 30. And that would be that 150. We would then draw our 30, 60, 90. Okay. How about 45? When would we have a 45-degree reference angle?
135.
Good. You can do that in your head. Just subtract 40 and then 5. 180 minus 40 is 140, minus 5 more. We would have a 135-degree angle. And then how about 180 minus the 60? What would we have?
120.
Excellent. So those are the three that we will see to get us in quadrant 2 that relate to the 30, the 45, and the 60-degree angles. But now that we're in these other quadrants, we really got to worry about whether things are positive or negative. We're not just playing in quadrant 1 where everything's positive anymore. Okay, let's go to the third quadrant. Let's go to quadrant 3. What do we say we would do to get our reference angles in quadrant 3? We would have to take that bigger angle of rotation, and we would just want to see how much more we went past the 180. So we're looking for the difference between our angle and that 180 degrees. And that's the symbol we use for difference, is subtraction. So if you want to use these three angles, you can also, instead of subtraction, if we're trying to find this, think about just adding it over. All right, solving for that angle that we're looking for, that we will see in quadrant 3. So go 180 plus 30, what are you going to be at?
210.
So thankful Luis is here. Thank you for answering, my guy. How about 45? What if we went 180 plus 40 and then 5? What's 180 plus 40?
220.
Good. Plus 5 more.
225.
Excellent, Charles. And then what about 180 plus 60?
240.
So now when you see these three things, you know that you will have been placed in quadrant 2 between the 180 and 270, just like over here. In quadrant 2, we were between 90 and 180 for everything. Why just these three are we talking about? What do they yield when we draw our right triangles? What reference angle from our origin? the 30, 45, and 60, those special angles that we should know. Maybe not yet, but we're working on it to memorize all of our trig functions for all three of these angles. And then, like I told you, in reality, all you need to memorize are half of them, because then the other half are complements of that. All right, let's move to the last, quadrant 4. In quadrant 4, how do we find our reference angle? Well, now we're going to have to go past the 270 and not quite to the 360. And whether it's a 60-degree angle, a 45, or a 30, with respect to my x-axis for each one of these things, what is that rotation going to give me? How are we going to find our angle? Well, if we go all the way to here, it's almost all the way around, a full circle, 360 degrees. So if that's the angle that we're traveling, and we want just this little angle that's left, the reference angle we call it, then we'll have to subtract off all of this from the whole circle to get what we want. So we will take 360 and subtract our angle in order to get it in quadrant 4. So how are we going to do that? Well, what's 360 less 30?
330.
Very easy. Let's do the next easiest one, 60. If I go all the way around to 360, but I want to come back to that 60-degree angle here, what's 360 less 60?
300.
Now, let's do it one step at a time. 360 less our 45. What's 360 minus 40?
320.
Minus 5 more.
315.
See, it's easier than trying to borrow and do that stuff in your head. Subtract the bigger numbers, you'll get it smaller faster. Okay? So these are the things that I want you to start now memorizing. And recognizing that anytime you see the 150, 330, 210, it's just going to be that 30-degree angle in a different quadrant. Or what else? 315, 225, 135. If it ends in a 5, I'm thinking it's a 45. If it ends in a 0, it's either the 30 or the 60. And then lastly, when you see the 120, 240 and 300, that would be our 60-degree reference angle, just in different quadrants. Okay, so the non-acute angles, we are going to make acute, but remember, you cannot forget what quadrant you're in, which takes us to that all students take calculus reminder of where things are positive versus negative. All right, so let's just do 2 quick examples here. Start with this first one. I'll put them both up, but it's going to require some participation. I wanted to show you that this is how you should be thinking about these. So first, somebody pick one of our reference angles.
30.
Now somebody pick a quadrant, somebody else.
Quadrant 3.
You guys are privy to the threes this morning. Okay. Now, what actual angle would give us that scenario? A 30-degree reference angle in quadrant 3.
210
Very good. How'd you get that so fast, Anissa?
from the table.
Ooh, good. Or hopefully you can visualize I had to travel 180 degrees plus how much more to get to quadrant 3?
30 more.
That's right. So you just took 180, added 30 to get our 210. Very good. So now what I want you guys to do is find all 6 trig values for 210. Without using the calculator, and I want the exact, therefore no calculator, value for each. And of all of these, how many do you actually need to find?
Only 3.
Which 3, Luis?
Sine, cosine, and tangent.
Our big 3, I like to call it, because those are the most important. Once we have these, what will we do to find these?
Get the reciprocal.
Very good, which means we will take their ratios and flip them. Excellent. I'll give you guys a minute to do that. Ready, go. All right, hopefully that was enough time for you all. If you're watching the video, hopefully you paused it and tried it on your own. If not, go ahead and do that now. But what did I tell you always helps? Almost always when you're doing these trig problems, just draw it out. Give yourself a quick little drawing. Now you don't need the whole thing because we said we're going to be in quadrant 3. But when I go to draw this angle of 210 degrees, we said we'd have to go the 180 plus that reference of 30 more. So to do that, I'd go 180 plus 30 degrees more. Now, do I need to draw it to scale and have it be perfect? No, that's the beauty of it. But I do know that if this is a perpendicular that I dropped to my, remember, always the x-axis, and this is 30 because we traveled 210 degrees, 180 plus that, then it's a 30, 60, 90. And therefore, you should already know all the ratios. Remember, when we are given this, we're always going to do it from the origin, our axes, and the angle. So what we're really looking at, my friends, is a bunch of 30-degree angles for all of these. And didn't we just review what the sine of 30 was?
One half.
Very good. How about the cosine of 30?
Square root 3/2.
Good. It had to be the other one, the root 3/2. And how about tangent of 30?
Root 3/3.
Excellent. Do you see why I want you to memorize these? Then you don't have to scramble through your notes. You don't have to look anything up. You just look up here and boom, write it down. Now, this is one of the biggest mistakes that students make, though. And you're like, wait, what mistake? What? I didn't do anything wrong. Luis is the man. What's our mistake? Anybody?
The sine.
Very good, Anissa. That's where the drawing comes in and helps. What do we know should be the only things that are positive since we went left and then down? And remember, our R is always positive.
So the cosine and the sine should be negative.
Very good. Which means so are what? their reciprocal functions, cosecant and secant. Does that make sense? So we're going to use that reference angle a lot, but don't get locked into just the values. Make sure that you also look and realize what you're actually evaluating and where that puts you, because that will depend on whether it is positive or negative. Otherwise, yes, these are the things that we want to focus on, but we can't forget about where we're at. So some of these are easier than others, like cosecant, flip, sine. It's the reciprocal function of it. What do we get?
-2.
2 over 1. We can just write 2. Beautiful. But when we flip this, not so nice. So we get 2 over root 3, which means we're going to have to multiply by that fancy 1 to get 2 root 3 on top and a 3 on bottom. So again, if you don't want to have to go through the motions of doing this to get that, then memorize this. That's fine too. And since this is the tangent of 30, we know that this would be the cotangent of 30. And do you guys remember what that one was equivalent to? The tangent of what? $60. And do you remember what the tangent of 60 was?
√3.
See how you can use some of that other stuff to still find that? Now, if you wanted to flip the root 3 over 3, like we did with the root 3 over 2 to get that, let me show you. 3 over root 3 is what we would get, right? Multiplying by that fancy 1 again, we get on top 3 root 3 over our 3, which then would cancel those out to get our root 3. However you get there, get there. The faster you memorize these, the faster you're going to be able to move on and not get hung up on just evaluating. Because once we've gotten through this, we're going to add more stuff to do and learn. Okay, so let's do a second example, and then we'll call it good for this. We'll take a little break, work on our group quiz for this part, and then wrap up today with 2.3. All right, so this time we're going to do it a little bit differently. Now I want somebody to pick a trig function. Anybody?
Cosine.
Cosine. Okay. Now somebody else pick a value or ratio that we should all know. It could be positive or negative, your choice. Somebody else other than Luis. Give me one of those ratios that we know or should know that you need to start memorizing. Okay, Luis, go ahead, buddy. It's just you and me today, buddy.
Do you want me to tell you if it's positive or negative as well?
Sure.
-1/2.
Beautiful. So if my scenario was that I told you we had the cosine of some angle equals -1/2, I want you to find all values of theta that would make that work. So what's the first thing you think that you should probably do? Let's figure out what quadrant we're in. And what's going to tell us what quadrant we're in? It's telling us that cosine's negative. That's what Luis chose. So what does that mean? Where would we be? Or where would we not be? Might be a better question.
We wouldn't be on top. So it would be one from the bottom. So
Careful.
4.
Careful. Remember, cosine is always the x over the r. So remember what this stands for is all of our trig functions are positive there. This only what? That S stands for sine. This only what is positive?
Tangent.
Tangent and cotangent.
Very good. I like how you threw that in. And what does the C stand for?
Cosine.
Very good, Estella. So since we know that cosine has to come out a negative value, we can right then and there throw out where it's positive. We are playing in quadrant 2 and quadrant 3. Everything to the left, actually, not up. Now, what's the second thing we need to know? We need to know the angle. And not just the angle to get here and here. We need to know the reference angle. And we will use the fact that we know that we're going to go back and more than that 180 degrees to find it. And do you all know what angle for cosine gives us the 1/2?
60.
I like how that was a slow question. I think it's that, Luis, because we're still working on memorizing these things. But you are correct, because remember the sine of 30 was 1/2, so the cosine of 60 is 1/2. So what are our answers? Now that we know this, and we know that we're in quadrants 2 and 3. What are we going to do with that 60 and that 180?
We're going to add 180 and subtract 180.
Good. We're going to subtract the 180 to get in quadrant 2. I should have said from 180, right? And then we're going to add to that 180 to get to quadrant 3. And the ratio for cosine that they were choosing, and I should say just he was choosing, Luis, was a 60-degree angle for that 1/2. So therefore, our answers are what and what?
120 and 240.
Just working backwards from what we've done in the previous. All right. That's it for this section. We'll go ahead and work on our group quiz for a little bit here, take a break, and then we'll come back and do the second section for today, 2.3. Get to work. All right, well, welcome back to our next section, 2.3. And as you can see, this is actually one of my least favorite sections. And it's all because of one word and one word only. Approximations. So we just discovered these new things called reference angles and how we can use those in any of our four quadrants to find the exact value for any of our trig functions. But how do we approximate things? Well, it's something, unfortunately, that is necessary, and they dedicated a whole section to it, but it doesn't happen that often in trig because we'd rather not have about what the measurement is. We want to know exactly. So what do we need in order to approximate instead of those exact values for the 30, 45, and 60 in any quadrant? What do you think? What would you need to approximate? Do you all know what the sine of 30 is?
One half, isn't it?
Very good. A few of you put that in the chat. Luis speaking up as usual. Appreciate it. We know it's exactly one half. Well, what's the sine of 40?
Good point.
Yeah, that it's not one that we know. If I said 45, then you should be able to tell me what.
Square root of 2 over 2 for sine 45.
Very good, Charles. Excellent. But we don't know that the sine of 40 is exactly. We know it's somewhere in between there because it's between 30 and 45. So it's between one half and whatever root 3 over 2 is, which means what do we need to get that approximation? We're unfortunately going to need a calculator. Now, again, you don't need a big fancy graphing calculator. You just need what is called a scientific calculator. All right, that will have sine, cosine, and tangent on it. Unfortunately, though, only the big three. Because what do we already know cosecant, secant, and cotangent are?
Reciprocal.
So if we know the big three, we can just flip it. Our calculator can do that for us too. Okay, so it's not just because I don't like this section of approximations, but there's just really not a whole lot for me to explain, derive, or give you a deeper understanding of. You just need to know how to use your calculator. So I said, here's your notes for the entire section. Make sure your calculator is in what? If we are evaluating these things. Well, you don't know any better yet. Not until we get to chapter 3 in a few weeks. But it has to be in what are called degrees. So make sure that your calculator, you know how to figure out how it possibly has changed out of that. Otherwise, most of them are already in that. But when we get to the next chapter, chapter 3, you have to change it to a new thing that's pretty cool. It's rad, actually. It's called a radian measurement. Okay. So if you see radian, rad for short, or even grad, which is gradients, which is more science stuff we won't even use in this class. These are the two that we will have to be able to toggle between and know when to use what. Okay. So there is one other piece of notes other than just making sure that your calculator is in degrees. We need to know what symbol operation, or of course button to push, when finding an angle instead of the ratio. So going back to that last problem we just did, that's the scenario I'm talking about. We actually weren't given the angle, we were given the ratio. So what do we want to be able to do when we are given something like cosine? Or let's mix it up, sine of what angle gives us 1/2? You all should know it's what?
Angle's 30.
You're halfway right, Luis. You get half credit. No pun intended. Why is that only halfway right? Is that the only angle for sine that gives us 1/2? No. There's also quadrant 2. So who can give me the other one?
Cosine.
So I'm just talking about this problem right here, Estella.
Oh, sorry.
It's okay. What angle would also give me 1/2 when I plug it in for sine?
$150.
Very good, Luis. How did we get that?
We subtracted 30 from 180.
Good. We knew that we only wanted to go 150 degrees, but we knew that the reference angle was 30 degrees. So we wanted to go 180 and then back that 30. So we just take that 180 degrees, subtract 30, and we got our second option. How are we going to punch that in our calculator? How are we going to tell our calculator that we want these without having to plug this in and see if it comes out 1/2? Plug in something else and see if it comes out 1/2. We have to introduce a little thing called the inverse. Because what we're doing is reversing the input and the output. So if I give you the sine of what angle gives me 1/2, what I'm really asking you is to do the inverse. And do you guys remember what symbol we use for inverse? To reverse the input and the outputs? It's that little -1 exponent. We also use in trig the acronym ARC. Okay, so arc sine, or that little -1 inverse sine of what equals what? Well, if we are doing the inverse, which stands for the reverse, inverse is just the fancy math term that we came up to represent reverse. Then that means I'm taking the input and the output and I'm swapping or reversing their places. Still dealing with sine, but I want to now know the angle, which means I want that by itself. And I know the ratio, but I have to tell my calculator that I'm not trying to take the sine of 1/2 of an angle, a degree. This is actually the y/r. And they are going to give us the angle that represents that. So let me show you what I mean here. Let me go to my calculator. Now again, make sure that whether you're using a big nasty graphing calculator like this or a simple, easy one, go to your mode and make sure that it is in degree measurements. Okay, I'm toggling between so that you can see the two. Make sure that you're in degrees. Then to do the inverse, you're going to have to hit that second or shift button to let them know, hey, I'm doing the inverse or arc sine of what value now? Well, that was 1/2. But here's the problem. Guess what they're only ever going to give you? One answer out. That reference angle. And notice they didn't give me both. They only gave me the 30 that we know already that the sine of that angle gives us that ratio 1/2. So what do you still have to go over here and do? You have to make sure that you give me both. And remember, there's always two quadrants that are going to give me a positive and two quadrants that are going to give me a negative value. So you should be giving me two answers because they asked for all the angles between 0 and 360. And I don't know if you guys noticed that there was a bracket around this and a parenthesis around that. That's not a typo. This, if you remember, includes and this excludes the value. And why did we include 0 and exclude 360? They are the same point. And it's easier to not go any than it is to go all the way around to get to that same point. All right. That's your notes for 2.3. Making sure that you know how to take the inverse whenever you're trying to find the angle instead of the ratio. So let's do one example and we will call it good for this section. Now don't forget, what does that symbol mean?
Minutes.
Very good. So I'm going to go ahead and pause it. I'll give you a few minutes, pun intended, to do all three of these, and then we'll compare our answers. And if anybody needs help, both Anthony and I will stick around and be able to kind of make sure that you guys know how to input this stuff for those of you that are actually here in your calculator. If not, and you need some help, you can go to the tutorial center or go to Anthony's different days or times that you are available and get some help on how to input these. All right, take a few minutes, try these. All right, hopefully you guys tried that on your own. We're going to go ahead and go over these, make sure that you understand. Now, remember, there's more than one way to do a lot of these. So if you didn't do it exactly the same way, but you got the same result, all good. Again, remember, whenever it says approximate, you're thinking, all right, calculator time. And just make sure that you look at what they want you to round to. And if they don't specify, remember our sig figs, that's what you would want to give out. So here 4, 3, and then a lot. Okay. So how did you do the first one? Well, I probably would have started by taking the 41 degrees and changed it to decimal. Unless you have a calculator that has the minutes. And remember, if we want to get rid of minutes, you can always multiply by that fancy one to get rid of it and change it to what we want. As long as you know that relationship, it's all good. And I know that 1 degree is equivalent to 60 minutes. And since each of those can be divided by 6, this works out pretty well. 6 goes in that 4 times, and this 10 times. But 2 can also go into that. But I don't care, because I actually want to change it to decimals. And I have 4/10 of a degree, then that means 0.4. So I can rewrite this as 41.4 degrees, and that's what I'm taking the cosine of. So I go to my calculator and I type in the cosine of 41.4 degrees, and that's what you should have gotten out to, of course, the 6 decimal places, which means we actually need to look to the 7th to see whether we go up or stay. And remember, there are 10 digits in our numbering system. There is the 0, 1, 2, 3, and 4. That's the first half. Then 5, 6, 7, 8, and 9. So anytime you have 0 through 4, that's why we stay. And anything 5 and above to 9, we move up because it's closer one half or the other. So for our answer, we should do 7, 5, 0, 1, 1, 1. And since it's a 0, we'll stay with the 1. So 750 with 3 ones. That's our approximation. If you want to include the 0 at the front, that's fine too. Okay, so then how did you do part B? Anybody find that button on their calculator? Well, remember, cosecant of an angle we went over earlier this week. We don't have a button for cosecant. So I can't just plug in the 38.6, hit a button, and be done. I got to rewrite it. And I have to rewrite it in terms of another trig function. So how am I going to rewrite cosecant of an angle? Does anybody remember what that's equivalent to in terms of another trig function?
Secant.
Okay, good. Charles, we could rewrite cosecant of my angle as secant, but it wouldn't be of the same angle. But it would be equivalent, so that would be okay. It would actually be
Sine. Oh,
90 minus that angle if we wanted to do that. But the problem is, Charles, we don't have secant on our calculator either. So very good. Somebody was mentioning sine. What about it?
it's equivalent to sine, isn't it?
Not exactly sine, but what?
Mm.
Oh, cos.
Nope, we're on
Oh,
a
no, not
better
cos.
track.
Oh, sorry.
It's okay. We're on the better track with Estella and sine. But remember, those are what are called reciprocal functions. So it has to be the reciprocal of sine. So since we know that these are equivalent, now we can plug in our angle because now we can use our calculator for that. So we're actually going to be putting in 1 over the sine of 38.6 degrees. And remember, guys, I told you this before, I hate calculators because they're never wrong. The problem is you are, right? The user that inputs things in a certain way, they can be wrong. So you got to make sure that you input this correctly, or you're not going to get the right answer. So if you're ever unsure, put an extra set of parentheses around things that you don't know if it's going to read it the wrong way. But that's what we would then have to go and do. So we say 1 over divided by our sine of 38.6. And that's what you all should have gotten. And remember, they asked for 6 decimal places. So we're going to have the 602873, and then we'll look to the next thing, which is also a 3. So that will stay the same as well. So 1.602873. And again, I'm putting the squiggly equals because this is what that is about. Now, on to the third and final problem for our calculator, approximates. And it is the most challenging. Because notice on the first two, they gave us the angle and the trig function and asked us to give them out the ratio. Now we couldn't give it to them exactly, so we put it in our calculator to approximate. This one was pretty straightforward, other than the minutes. May had to have changed that. This one, not as easy because it wasn't one of our big 3. So we had to do the reciprocal of what we know that is equivalent to get our approximate. But why is this one more challenging? Not only did they give us one of those other reciprocal functions, not our big 3 sine, cosine, or tangent, they also now are asking us for the what? The angle instead of that big old nasty approximate ratio or decimal. So we got a couple of things going on here. One is we have to take this and we're going to have to use the what in order to find the angle.
Would it be the inverse?
Very good, Estella, it would. But before you go moving things around, let's get a trig function that we can use first. And if you remember, cotangent can be
Tangent.
very good. How, Estella?
I just input it in my calculator.
As what?
The inverse of tangent, and then I put the 6.4358841, and I got 81.168073.
So careful, it was 5.242184. Right? But just like over here, I like to generalize it for you because this can get ugly. We want to know what cotangent for some angle is equal to, and we know it's but is it exactly tangent? Is tangent of an angle equal to cotangent of an angle? No, remember they too are reciprocal functions, just like cosecant and sine are. So what I'm going to do is I'm going to rewrite cotangent as 1 over tangent, because I know they're equivalent. So that would also have to be equal to this. Oops. 2.42184. But I don't like the fact that I got 1 over tangent. It's better than cotangent because I have this, but I don't want to write all of this like that. I would rather this just be what? How about just tangent? Wouldn't that be better? But what did I have to do to this to get that? I had to flip it to make it tangent over 1. Which, if I want to keep it equal, I have to flip the other side as well. So I'm going to get 1 over 5.242184. And now, and only now that I have something that I can actually use in my calculator, will I then take and reverse or do the inverse of with my input and output. So now I have that arc or inverse tangent of 1 over 5.242184 equals my angle. Now I have what I want by itself. I just got to punch this into my calculator. And to Estella's point earlier, and this is why I hate this section, even though we got to cover it, it's a must. We can't just only have 30, 45, and 60 in any quadrant. There are going to be times when we deal with different or not so nice things in life. You guys know that. Is this correct? Is this correct? Do you have a feel? Stella told me the answer was 81 point blah, 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 blah. Is that right?
It's 79, I think. I could be wrong again.
Exactly. We don't really know. And that's why these are tough. So really try to pay attention, break it down to the basics, and then use your stuff. Okay, but that's why this one is challenging, and that's why I wanted to go over 3 different scenarios. A basic, here's an angle, here's a function, give me the approximate. Here's one that you gotta rewrite and then use the angle to approximate. And then this one, we not only had to rewrite by doing the reciprocal, we also then had to do the inverse to find the angle measurement now. So let's go and see what we end up getting. So we got inverse tan of 1 over 5.242, 184. So we're going to do the inverse of tangent of 1 over, it was 5.242, 184. Make sure you close your parenthesis.
Oh, I forgot to put the 1 over.
And that's a big mistake.
Yeah,
Because otherwise you're doing cotangent.
just the inverse. Yeah.
So again, unfortunately, there's a lot of 9s there, but we end up with 10.799999999. And we got to take it out to that 6th decimal place again. So 1, 2, 3, 4, 5, 6 would be the last 9 actually, because there's 5 of them there. So we look to the 1 and we would keep that. 10.79999. So be careful. These can be tricky. All right. We want to make sure that we try to keep it as simple as possible. So I advise you all to get something that you can use if it's not already given that way. Before you start trying to just punch things into your calculator, because you will get an answer out. It just may not be the correct one. All right. I'll stick around along with Anthony. Make sure that anybody needs some help with these. You can finish up that group quiz number 3.2, which is the 2nd installment for the whole week. And remember, both 3.1 and 3.2 together are due by Sunday at midnight. Plenty of time to get help. Go see Anthony. He's a good guy, and he will help you to get through any problems that you're struggling with. All right. Take care, everyone. Have a great weekend, and go Niners.